Today, new daily challenge to retrieve a solely maximum non-negative product in a matrix. We're given a matrix here, m multiplied by n, and we need to find out the maximum non-negative here multiplied by modulo. And if it doesn't exist, like in this case, we should return -1. So it is basically finding the path here. Start our implementation. We're gonna use mn standard one. Gonna get the grid and length of the grid 0 element, which means it's row and column here. Let's define our mode, which is 10 multiplied by 9 plus 7. Let's generate our two dynamic programming tables. We're gonna use dynamic programming approach as suggested in hints for in range of m, and second one mean dynamic programming is 0 multiplied by, let's define 0 element, multiplied by n for in range of m. Initial element will be the 0, 0. It will be assigned to 0, 0 of minimum 1 and assigned to grid 0 initial element. So at the first step, we're gonna iterate over the column and load our new matrices. So we got the value grid I 0, and we're assigning new elements here I 0, assigning it previous one, basically I minus 1, 0 multiplied by value, and minimum one is I 0, basically the same multiplied by minimum I minus 1, 0 multiplied by value. The seeds one, and for the first row in range of in, we're gonna get the current value, which is grade 0j, and we're gonna assign maxdp 0j to maxdp of 0j minus 1 multiplied by value, and minimum one is 0j. It's basically the same one, the 0j minus 1 multiplied by value. We have defined our initial states here, and let's iterate. Basically what we got here is like this. So we assigned here the row and the column here, and these values will be covered as next iteration. With the next one, we're gonna iterate over all other elements, starting from 1 until m, for j in the range starting from 1 until n. We're gonna get the current value, which is ij, of course. All possible solutions here, let's call it candidates here as an array. And let's start. So value multiplied by maxdp of I minus 1 j, first one, second one, minimum I minus 1 mul j, second one is value multiplied by maximum of ij minus 1, let's cut it minus 1 like this, and last one is ij minus 1. Basically all possible, all nearest from the left and from the top here. And let's assign our maximum to new maximum candidates and new minimum to the new minimum, of course. So it will be minimum of the all possible candidates. So we're switching these two states here, and the result is maximum, since we find out maximum m minus 1 and minus 1. So this is the result. Found some result, we divided by module. If result is greater than 0, in other cases return -1, since we didn't get the answer or it's negative, so we don't need it. So thank you guys for watching. See you next day.